According to the National Electrical Code Section 406.4d5, GFCI protection is required for all 125-volt, 15 and 20 amp receptacles installed outdoors and in specific indoor locations. These locations include bathrooms, garages and accessory buildings, kitchens, laundry areas, crawl spaces, unfinished basements, and wet bar sinks. The National Electrical Code does not explicitly mandate GFCI protection for light switches near doors. It's important to remember that some local codes or jurisdictions may have additional requirements that go beyond the National Electrical Code. Always verify local building codes and regulations with a local building inspector or electrical code official in your area to ensure compliance. Even though the National Electrical Code does not specifically require it, installing light switches on GFCI protected circuits can provide an extra layer of safety, particularly in areas where water is present or where electrical appliances might be used. GFCI devices are designed to trip, meaning they cut off power to the circuit when they detect a ground fault, thereby preventing electric shock. Ground faults can occur with light switches, even if the wiring is damaged or faulty, thus creating a potential hazard. While the National Electrical Code does not mandate it, installing light switches near doors on GFCI protected circuits is often recommended for added safety and protection. This is especially prudent in damp or wet locations. To further expand on the concept of GFCI protection, it's essential to understand how these devices function and why they are so effective at preventing electrical shocks. GFCI stands for Ground Fault Circuit Interrupter. A GFCI constantly monitors the current flowing into and out of a circuit. In a properly functioning circuit, the current flowing into the circuit should equal the current flowing out. If there is a difference, even a very small one, it indicates that some of the current is leaking to ground. This leakage is known as a ground fault. A ground fault can occur when someone touches a live wire or when a faulty appliance allows current to flow through its enclosure to ground. If this happens, the person or the appliance becomes part of the electrical circuit, and current can flow through them to ground, causing an electrical shock. GFCIs are designed to detect these small imbalances in current flow. When a GFCI detects a ground fault, it quickly trips the circuit, interrupting the flow of electricity in as little as 1/40th of a second. This rapid response time is crucial because it can prevent serious injury or even death from electrical shock. The threshold for tripping is very low, typically around 5 milliamps, which is far below the level that would cause significant harm to a person. There are two main types of GFCI receptacles and circuit breakers. GFCI receptacles are installed in place of standard electrical outlets. They have a test and a reset button on the face of the receptacle. These are commonly found in bathrooms, kitchens, and other areas where moisture is likely to be present. GFCI circuit breakers are installed in the electrical panel. They provide GFCI protection for the entire circuit, including all the outlets and devices connected to that circuit. When a GFCI trips, it needs to be reset. To reset a GFCI receptacle, you simply press the reset button. To reset a GFCI circuit breaker, you need to turn the breaker off and then back on. If a GFCI trips frequently, it could indicate a problem with the circuit or an appliance connected to the circuit. In this case, it's important to investigate the cause of the tripping and correct the problem. This might involve checking the wiring, replacing a faulty appliance, or calling a qualified electrician. Regarding specific National Electrical Code requirements, it's important to consult the latest edition of the National Electrical Code and any applicable local amendments. The National Electrical Code is updated every 3 years, and the requirements can change from one edition to the next. In addition to the sections mentioned earlier, other sections of the National Electrical Code may also be relevant to GFCI protection. For example, Section 210.8 provides more detailed requirements for GFCI protection in dwelling units. It's also important to understand the difference between GFCI protection and standard grounding. Grounding provides a path for fault current to flow back to the electrical panel, which can trip a circuit breaker and de-energize the circuit. However, grounding alone may not always prevent electrical shock. A GFCI, on the other hand, directly detects imbalances in current flow and interrupts the circuit, providing a much higher level of protection. In some cases, both GFCI protection and grounding are required. For example, receptacles installed in bathrooms must be both GFCI protected and grounded. The recommendation to install light switches on GFCI protected circuits is based on a principle of providing the highest possible level of safety. While light switches may not be directly exposed to water, they can still be susceptible to moisture or damage that could create a ground fault. By installing light switches on GFCI protected circuits, you can reduce the risk of electrical shock and improve the overall safety of your electrical system. As previously mentioned, local codes and regulations may have specific requirements for GFCI protection that go beyond the National Electrical Code. These local requirements may be based on specific hazards or conditions that are present in your area. To summarize, while the National Electrical Code does not explicitly require GFCI protection for light switches near doors, it is recommended for added safety. Always check with your local building inspector or electrical code official to determine the specific requirements in your area. Understanding the function and benefits of GFCI protection is essential for ensuring electrical safety in your home or building. GFCIs are a proven technology that can significantly reduce the risk of electrical shock. By installing GFCIs in appropriate locations and following all applicable codes and regulations, you can create a safer electrical environment for yourself and others. Furthermore, consider the specific environment where the light switch is located. If the light switch is in a potentially damp or wet location, such as near an entryway that is frequently exposed to rain or snow, the argument for GFCI protection becomes even stronger. Water is an excellent conductor of electricity, and even a small amount of moisture can create a pathway for current to flow to ground. In such cases, the added protection provided by a GFCI can be invaluable. When installing a GFCI protected circuit, it's important to use appropriate wiring methods and materials. The wiring should be properly insulated and protected from physical damage. All connections should be tight and secure. If you are not comfortable working with electricity, it's best to hire a qualified electrician to do the work. Working with electricity can be dangerous, and it's important to take all necessary precautions to avoid electrical shock. Always turn off the power to the circuit before working on any electrical components. Use insulated tools and wear appropriate personal protective equipment, such as rubber gloves and safety glasses. Double-check all connections and wiring before restoring power to the circuit. After installing a GFCI, it's important to test it to make sure it is working properly. To test a GFCI receptacle, simply press the test button. The GFCI should trip, cutting off power to the receptacle. To reset the GFCI, press the reset button. To test the GFCI circuit breaker, turn the breaker off and then back on. If the GFCI does not trip when you press the test button or turn off the breaker, it may be defective and should be replaced. Regular testing of GFCIs is recommended to ensure that they are functioning properly. Another aspect to consider is the type of light switch being used. Some light switches are more prone to ground faults than others. For example, older light switches with metal housings may be more likely to develop ground faults than newer light switches with plastic housings. If you are replacing an old light switch, it's a good idea to replace it with a newer model that is less likely to cause a ground fault. The cost of GFCI protection is relatively low, especially when compared to the potential cost of an electrical shock. GFCI receptacles and circuit breakers are readily available at most hardware stores and electrical supply houses. The installation cost can vary depending on the complexity of the job and the location of the circuit. However, even with the added cost of installation, GFCI protection is a worthwhile investment. In addition to GFCI protection, it's also important to have a properly grounded electrical system. Grounding provides a path for fault current to flow back to the electrical panel, which can trip a circuit breaker and energize the circuit. A properly grounded electrical system can help to prevent electrical shock and reduce the risk of fire. To ensure that your electrical system is properly grounded, it's important to have it inspected by a qualified electrician. The electrician can check the grounding connections and make sure that they are in good condition. They can also test the grounding system to make sure that it is functioning properly. Also consider arc fault circuit interrupters, or SIs. While GFCIs protect against ground faults, SIs protect against arc faults. Arc faults are dangerous electrical conditions that can cause fires. They occur when electricity jumps between two conductors, creating a spark. SIs are designed to detect these sparks and trip the circuit, preventing a fire. The National Electrical Code requires this size in many locations, including bedrooms, living rooms, and dining rooms. While SIs are not specifically required for light switches, they can provide an added layer of protection against electrical fires. It's important to understand the limitations of GFCI protection. GFCIs are designed to protect against electrical shock, but they do not protect against overloads or short circuits. Overloads occur when too much current is flowing through a circuit. Short circuits occur when there is a direct connection between two conductors. Overloads and short circuits can cause wires to overheat and start fires. To protect against overloads and short circuits, it's important to use circuit breakers or fuses that are properly sized for the circuit. Circuit breakers and fuses are designed to trip and interrupt the circuit when an overload or short circuit occurs. In summary, while the National Electrical Code does not explicitly require GFCI protection for light switches near doors, it is recommended for added safety, especially in damp or wet locations. Always check with your local building inspector or electrical code official to determine the specific requirements in your area. Understanding the function and benefits of GFCI protection, as well as other safety measures such as grounding and SIs, is essential for ensuring electrical safety in your home or building.